Hello and welcome to this video on algebraic expressions. Today we're going to be going over index laws, expanding brackets, factorising, surds and rationalising denominators. So first of all we have index laws. So you can use the laws of indices to simplify powers of the same base. And there are essentially around 8 laws if you think about it. And these are am times a to the power of n equals am plus n, am divided by an equals am minus n, am to the power of n equals amn, ab in brackets to the power of n equals an bn, a 1 over m equals m square root of a n over m equals m square root of an, and a minus m equals 1 over am. Finally, a to the power of 0 is 1. So an example is to simplify x to the power of 7 plus x to the power of 4 all over x to the power of 3. So first of all, we want to split this up into two parts, x to the power of 7 and x to the power of 4, each individually over 3, and then we can use the index law and divide by it, getting x to the power of 4 plus x. Now, for example 2, we have 25 to the power of minus 3 over 2. So here we're going to be using two laws. First of all, putting it in a fraction 1 over 25 to the power of 3 over 2, and finally we have 1 over the square root of 25, which is 5 to the power of 3, which is 125. Next we move on to expanding brackets. So to find the product of two expressions, you multiply each term in one expression by each term in the other. So here we can see from example 1, which will come up just in a second, if we have x minus y squared, this means that it comes twice, so x minus y times x minus y, multiply x by x, and x by minus y by x, and minus y by minus y. So we have x times x times minus y plus x, and minus y times minus y, and we add all these together, giving us x squared minus 2xy plus y squared. Now, for example 2, we have x minus 4, x plus 3, and x plus 1 all in brackets. So what we can do is we can take a pair at a time. So first of all, let's go through x plus 3 and x plus 1. So multiplying each term in one expression by each term in the other, we end up getting x squared plus 4x plus 3, and then we bring down x minus 4, and then we just do the same. We multiply each term in the first expression by each term in the second, and this means that we have x cubed plus 4x squared plus 3x minus 4x squared minus 16x minus 12. 4x squared appears twice, so we get rid of it. 4x squared and minus 4x squared. Finally, finish off. And then now we have factorising. So this is the opposite of expanding brackets. So what you have to do is you must find the common factor of an expression and take it out. And by what that means is you, in a way, divide by it. And then you put it outside in a bracket. So for example, if we had 8x squared plus 20x, we would see that 4x was there in both situations, so we divide by that. In a way, we'd be taking it out. So we have 8x squared over 4x plus 20x over 4x, which gives us 2x plus 5, and then, as I said, we put 4x in the bracket. So there's also, this will be a bit more challenging, but there's factorising quadratics, where a quadratic is anything in the form a, x squared plus bx plus c, where a, b and c are real numbers. And this essentially has 4 steps. 1, find 2 factors of ac that add up to b. Then 2, now that we've found those factors, we want to rewrite b as the sum of them. And then step 3, we want to factorise each pair of terms, which is what we've just shown. And finally, we want to take out the common factor. So let's show an example of this. We have 2x squared plus 5x minus 3. And AC will be 2 times minus 3, which is minus 6, and b is 5. So what gives minus 6 when we multiply them? Well, minus 1 times 6 gives minus 6. What adds to 5? Minus 1 plus 6 adds to 5. So now let's split 5 into minus 1 and 6. So we have 2x squared minus x plus 6x minus 3. Now we take the 2 halves of it and factorize them. So in the first one we take out x, and in the second one we take out 3. And now we can see that we have a common factor of 2x minus 1. So we take that out and we're left with our answer. So finally, there is one last rule, and this is called the difference of two squares, and it's essentially anything that's in the form of x squared minus y squared can be simplified to x plus y and x minus y. So this, for example, x squared minus 25, this is x plus 5, x minus 5. Moving on now to surds. So surds are irrational numbers, meaning that they can't be written as fractions, where the numerator and the denominator are whole integers. And they're basically multiples of roots, which is anything in the the square root of n. So for example, 3 square root of n or 20 square root of n, pretty much anything. So surds can be manipulated by two basic methods. The first one is if you have the square root of ab, this can be written as square root of a times square root of b. If you have the square root of a over b, this can be written as square root of a over the square root of b. So let's look at an example now. We have 5 square root of 6 minus 2 square root of 24 plus the square root of 294. The square root of 24 can be written as square root of 4 times square root of 6, and square root of 294 can be written as square root of 6 and square root of 49. So now we can see that we have square root of 6 present everywhere, so we factorize by this. And then if we simplify the bits that are inside, we get the whole number 8, so our answer is 8 square root of 6. Moving on finally to rationalizing denominators. So if a fraction has a surd in the denominator, it's useful to rearrange it using the following rules. Here there's essentially 3 rules or methods to manipulate these irrational denominators. So we have 1 over the square root of a. We multiply both sides, meaning the numerator and the denominator, by the square root of a. If we have 1 over a plus b, we multiply both by a minus the square root of b. And if we have 1 over the square a minus square root of b, we multiply by a plus the square root of b. And why can we multiply the numerator and the denominator by the same value? Well, really, if you think about it, we're actually just multiplying by 1, and there's no harm in this. So this is why it allows us to do this. So now let's go over some examples. So if we have the 1 over the square root of 3, we'd be using the first method. So let's multiply both sides by the square root of 3. And that will leave us the square root of 3 over 3, meaning that we no longer have a surd in the denominator. Now for example 2, we have 1 over 1 minus square root of 3 squared. So first of all, let's expand the brackets as we have just learned how to do. And we're left with 1 over 4 minus 2 root 3. So this means that we're using the last rule, so we multiply both sides by 4 plus 2 square root of 3. So let's go ahead and multiply that, and once again we want to simplify the bottom, we have to expand the brackets, and here we can see that we have a common factor of 2 on both sides. So if we divide by it, we're left with 2 plus square root of 3 over 2, so we can see how we have rationalized this denominator. So thank you for watching this video, and there will be a worksheet with questions and answers in the description.